Good morning, this is Unit 3, Day 1 Notes. Today we're going to talk about vectors in the coordinate geometry. We're supposed to suppose I is a translation on the positive x direction and J is a translation in the positive y direction. The point P of xy has the position vector, the origin to P, which is, we can write as xy, no fraction bar. And this is called the component form. Or we can write it as xi plus yj, and this is called the unit vector form. The magnitude or length of the vector is going to be like the distance formula to find the length of a vector. We use this symbol. I have also seen two lines on each side. It is equal to the square root of, we're going to start with v sub 1, but then we're going to square it. And then plus v sub 2, also the bottom one, and we're also going to square it. So that's to find the magnitude or the length of a vector. So let's look at this example over here. OA, or O to point A right here, maybe this is A. Vector OA is equal to, I comes first, those are my x values. It looks like we go 2 units in the positive x-axis, so 2i, and then plus, it looks like my y values, I'm going to go up 1, 2, 3, 4, so it's going to be 4, and then j. We can also write this as in the component form. We're going to see this often as 2, 4. The length of OA, let's try to find the magnitude or the length of OA, is the square root of 2 squared plus 4 squared. I know the 2 squared is 4 plus 16, which is the square root of 20, which is about, actually let's keep it exactly 2 square root of 5. Okay, so let's look at the algebraic operations with vectors. A negative vector has the same length, it just goes in the opposite direction. So if it has A1, A2, then negative A has negative A1 and then negative A2. Let's look at this one over here. This, we'll say, is my vector A. We use a lot of U's and V's also, but let's say that this is A, which is, it looks like 2 units to the left. So I'm going to say negative 2, and we're going up 1, 2, 3, so 3. Then negative A is positive 2, and then negative 3. We change both. So positive 2 means we're going to start up here, we're going to go 2 units to the right, and then negative 3, we're going to go down 3. So this is my negative A. Vector addition, we kind of touched on this a little bit last class. if we have A is A1, A2, and B is B1, B2, then A plus B is A1 plus B1 and A2 plus B2. We can try an example of this. Let's say that this one is P, which is 1, 2, 1, 2, 3. And this is Q, which is about 1, 2, 3, 4, 2. Then P plus Q is, we're gonna write P first. And I'm going to go over 2, start right here. I'm gonna go over 2, up 3, and right here. It would be kind of nice to use a ruler. I'm gonna try this, see if it works. Let's try it. Okay, and then we're going to add on to that Q, which we're gonna go to the, we're gonna start right here. We add on to the tail, we go over 4, and then up 2. We're gonna end right here. So if you have a ruler, this would be the time to use it. Now, when we add them, we start at the beginning and we end at the very end. So we're going to make this one red. I'm gonna try to stay consistent. And this red one is going to be P plus Q. Which actually we can count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6, 5 is P plus Q. And that is just adding 2 plus 4 and then 3 plus 2. Gave us the same thing. Vector subtraction is going to be the same thing. We know, oh, I put this up here. I put it in the wrong area. Vector subtraction is going to be very similar. So if this is A and B, A minus B is A1 minus B1, and then A2 minus B2. So we can, you guys can try an example of those if you would like. Go ahead and flip your paper over. Let's do an example. Let's try, given P is 3, negative 2, Q is 1, 4, R is negative 2, negative 5. What is Q minus P? Well, Q first is 1, 4. And P is 3, negative 2. So when I subtract those, I get 1 minus 3, which is negative 2, and then 4 minus negative 2, which is 6. If I had tried this geometrically, it would have given me the same answer, negative 2, 6. Now, I want you guys to try P minus Q minus R. Try that one out. It says given BA and BC, find AC. But AC is AB plus BC. We already have BC. All we need is AB. I know AB is the negative of BA. And then we still have BC, which we actually have. Well, the negative of BA is 2, negative 3. plus BC is just negative 3, 1. And if I just add these together, then I have to distribute this. Negative 2 plus negative 3 is negative 5. And positive 3 plus 1 is 4. Scalar multiplication, let's try this. So they're asking us to find P, which we know is 1, 4. Plus 2 times Q, which is 2, negative 3. This is pretty simple. I'm going to just rewrite 1, 4. 2 times 2, 3 is 4. 2 times 3 is negative 6. So when I add these, I get 5. 1 plus 4 is 5. And 4 plus negative 6, we get negative 2. This is going to be pretty much the same thing. You're going to divide P by 1/2 by 2, and then we're going to multiply Q by 3 and then subtract them. Let's try to find the magnitude. Remember, this means magnitude. Sometimes you'll see two sets of lines. Whenever we see something like this, we're asked to find the magnitude, we're trying to find a number. So we want Q minus 2 times P. Q, I think, was 2, negative 3. Minus 2 times P. And P was 1, 4. Or is 1, 4. Alrighty. And now I'm just going to rewrite my magnitude symbol. I want to do this part first before I actually do the magnitude, but I don't want to forget about it. So I'm going to rewrite this symbol. 2 minus 2 is 0. Okay, 0 is fine. Negative 3 minus 8 is negative 11. I need to find the magnitude of this still. So what we're going to do is take the square root of the first one squared plus the bottom one squared, which is 121, square root of 121, which is 11. Should always get a positive number. Alrighty. Go ahead and flip your paper over. It says the vector between 2 points. In the diagram, point A has a position vector. A has a position vector 0A, which is A1, A2. Yeah, it says A1, A2. So I'm just going to put that A1, A2. And point B has the position vector. Point B has the position vector 0B, or origin to B, which is B1, B2. Okay. Now they're asking us to find the vector A to B. Oh, but A to B is A to O plus O to B. So we know that this is A, starting at A, going to O, and then O to B. So I'm going to write that out. Starting at A to O, that vector, plus O to B. We know O to B, but we don't have A to O. But I know that this is just the negative of I can reverse this, the negative of O to A, which we do have, plus O to B. This one I'm not changing, the order. So I'm trying to find this point to this point. So I'm going to have to go the long way. Go this way and then back up. I can also put this one first. This is the same as O to B minus the O to A. I'm not changing, I'm just changing this order, which is O to B is B1, B2. We talked about this already, B1, B2, minus O to A is A1, A2. And this is all we would have to do, whatever those A's and B's are. So it says the position vector of B relative to A is A to B. Relative to A. So the position vector of B relative to A, these are special, is A vector AB. And we said this is equal to O to B minus O to A, which is equal to B1 minus A1 over B2 minus A2. Okay, let's try an example of this. Given this A, B, and C, find the position vector and its length from B of B from O. From O to B is 3 to 4. That one was easy. Now, from B to A, of B from A is A to B, which is O to B minus O to A. Now, given these points, we can actually figure out what this is. O to B, we know, is 3 to 4, 3, 4, minus A is negative 1, 2. And this is going to give us A to B, which is equal to 4, 6. I want you guys to try this one, please. Try A to C. So A from C, which is CA, which will equal O to A minus O to C. Try this one. Okay, let's try a couple of these. Example 5, it says find A to B, AB, and AC. So let's do that over here. AB is O to B minus O to A, which is so this is O to B is 3, 5 minus A is 1, 2. This equals 2. 5 minus 2 is 3. A to C. A to C. 4, -1, 1, 2. And that equals 3. And then -1 minus 2 is -3. Okay, I want you guys to try this one. Just explain, do the math, and show that these are equal. And I want you guys to find this one. Find B to C. We did the other two. So you can find B to C. Okay, we have an example of the coordinate geometry. So they're saying find the coordinate of point B if C is the center of the circle with diameter AB. We know that if C is the center and this is the diameter, then the distance between A and C, this vector, is going to be equal to this vector. So not only is the length going to be equal, but the direction is going to be the same. So this vector is going to be the exact same as this vector. So if they give us a point for A and C, we can find B. So we have A is 3, -2, and C is 1, 4. We're trying to find B, which is going to be XY for a minute. We're going to need this. Okay, so AC, we know AC is equal to CB. They have the same direction and the same length, so they're equal. A to C is C minus A, so 1, 4, 1, 4 minus 3, -2. And this is equal to C to B, or B minus C, which is X minus 1 and Y minus 4. I'm just going to simplify the left-hand side. This is -2, 4, 6 is equal to X minus 1. I can't simplify the right-hand side, but I can kind of take these apart and solve. I know that X minus 1 has to equal -2. I can solve for X now and find out what X is. If I add 1 to both sides, then I know that X is equal to -1. I'm going to do the same thing with Y. Y minus 4 has to equal 6. If I add 4 to both sides, then Y is equal to 10. And when I put these together, B is going to be -1, 10. Make sure I did that math right. Alrighty. This one's pretty cool. It says, use the vectors to show that ABCD is a parallelogram, where A, remember when we order our parallelogram, it doesn't really matter where you start. You can start at any of the 4 vertices, but we have to go around in a circle. So if you put A right here, B has to be the next one, and then C. Some people have the like some people start A right here and then B, and then they want to put C right here. It doesn't go right here. You have to go around in a circle. So C has to go right here, and then D has to go right here. All right. We want to show that this is a parallelogram. So what we're going to show is that A to B and D to C are equal. That means that they're going to be parallel and they're going to be equal in length. And that is going to be enough to prove that this is a parallelogram. So A to B is B minus A, and B is 3, 1, and A is -2, 5. I always want to put a fraction right there, a little fraction bar. So 3 minus -2 is 5, and 1 minus 5 is -4. So this is AB. Now we need to also find DC, this one, which is C minus D, and C is 2, -1. D is -3, 3. I don't know why it took so long. And 2 minus -3 is 5. And -1 minus 3 is -4. So we say since, therefore, since AB, the vector AB is equal to the vector DC, ABCD is a parallelogram. I want you guys to try number 8, and then you guys have some classwork problems to do. This is actually classwork, so make sure you guys do this. Thank you. Have a wonderful day.